this video, we're taking notes on solving radical equations graphically and algebraically. So you can read those directions, and I want to start with the definition here. The definition is a radical equation is an equation, so it has to have an equal symbol in it, that has a variable you are solving for, like an x, underneath the radical sign. Remember, the radical was a square root sign, or it could be like a cubed root or a fourth root, any of these that have the square root symbol. So which of the following equations are radical? A is a radical because it has an x underneath the radical sign. B is not radical, although it has a square root symbol in it, there's no letter underneath. C is a radical equation because it has an x underneath a square root sign. Then this is supposed to be clever. X is not equal to conservative, which means it's radical, so that would be an answer as well, and that's where the check comes from. So let's solve some radical equations by graphing. Number 1 says solve by graphing. We know that when we graph to solve an equation, we graph the left side of the equation. This is going to make the half a sideways parabola. The minus 1 on the inside scooches us 1 to the right. Remember, our parent function for a y equals the square root of x. The square root of 0 is 0. The square root of 1 is 1. The square root of 2, ooh, I don't like that one. The next thing I like to square root is 4. The square root of 4 is 2, or the square root of 9 is 3. Those are the points that I'd like to put in my picture. And I'm just scooting them all 1 to the right. So from my anchor point, 1 to the right, I'm going to go over 1 up 1. I'm going to go over 4 up 2. And I'm going to go over 9 up 3. So here is the square root of x minus 1. Then I'm going to graph 3. Y equals 3 is a horizontal line up 3 units. If I'm solving an equation graphically, I'm telling at what value do these two things intersect. They intersect right here. The x value of that point was 10, so my answer is x equals 10. Go ahead and try number 2 while you pause the video. In this one, we're going to have a plus 1 on the inside, which will move us 1 left. We're going to have a times 2 outside, which is going to stretch us times 2 vertically, and a plus 4 outside that's going to move us up 4. So go ahead and pause the video while you try and graph that one. So I graphed both sides and looked for the x value where they intersect, which was 3. Remember, the only reason I care about the x value is because the original problems of these had x's. The y value of the points of intersections don't matter because there were no y's in my original equation. Now we're going to go back to solving an equation algebraically. That should say algebraically. It says solve the equation by using square roots. Show all your work. If we had this equation, x squared equals 4, and we wanted to solve it, to get rid of the squared, I can take the square root of both sides. So if I square root both sides, I have to put a plus or minus, because I could have been either a positive or a negative square root of 4. And since the square root of 4 is 2, I have two solutions. X could be positive 2 or negative 2. The fact that these are solutions means if I plug them into the original equation, they're both going to work. So let's turn the page. On number 4, it says your friend Ian Inverse is solving some math problems. Read and complete the following. When solving 2 times x equals 16, Ian Inverse will what? Both sides by 2. He'll divide both sides by 2. When solving x divided by 3 equals 3, Ian Inverse will multiply both sides by 3. Ian knows that x divided by a times a equals x, and ax divided by a equals x. Ian also knows that multiplication and division are inverse operations. When solving x squared equals 4, Ian Inverse will square root both sides. When solving the square root of x equals 3, he has to inverse. And what's the opposite of square rooting? That would be squaring. So to undo square rooting, we need to square both sides. And here it says we know that the square root of x squared equals x, and the square root of x with the squared on the outside also equals x. So squaring and square rooting must be inverses. Now in here we have to be a little careful with positives and negatives, but we'll touch more on that in a minute. So number 5 says fill in the blanks to solve the square root of x equals 3. What would you need to do to both sides? Well, if you're trying to get rid of a square root, you're going to do the opposite of square rooting, which is square. If we square both sides, the square root of x squared is x, and 3 squared is 9. So our answer is x equals 9. It says check your answer by plugging back into the original equation. If I go to my original equation and plug in a 9, is the square root of 9 equal to 3? Yes, it is. Down at the bottom here it says, do we have to check our answers? Yes, here is why. There is no squaring property of equality, like there was for addition and subtraction, or also multiplication. Squaring both sides of an equation sometimes creates extraneous solutions. You remember these from things like absolute value or rationals, where we got an equation with an answer, but when we plug the answer in, it doesn't work. So let's look at an example of this down here. We have x equals 1. This is a single equation with a single solution. X is just equal to 1. If I square both sides, I have x squared equals 1 squared, which means x squared equals 1 again. Then if I take the square root of both sides, I would have to put a plus or minus when I take the square root. So I would wind up with x could be plus or minus 1. So I pick up an extra solution when I square both sides. Sometimes this happened, sometimes it doesn't. These are just like absolute value equations. When solving square root equations, you must check your solutions. So let's look at 6. 6 is actually quadratic. I have 2x squared minus 1 equals 11. If I'm going to solve this equation, what I try to do is I try to isolate the x, get the x by itself. So I'm getting rid of the thing with the squared. I would do that by adding 1 to both sides. And then I divide both sides by 2. So 12 divided by 2 is 6. Then I have x squared equals 6. I need to get rid of the squared, so I square root both sides. So I have the square root of 6. I need to put the plus or minus in there because it could have been either 1. And that's my answer. X is plus or minus the square root of 6. All right, let's turn the page. So now we have to solve a similar equation, except for instead of a squared, it has the square root in it. But I'm still going to follow through the same idea. I'm going to add 1 to both sides, which gives me 2 square root of x equals 12. Then, to get rid of the 2, I'm going to divide both sides by 2, which gives me the square root of x is equal to 6. Now I need to undo square rooting. To undo square rooting, I would square both sides. So I have 6 squared, which is 36. I think this is my answer. I always need to check my answer by plugging back into the original equation up here. If I plugged in the 36, I'd have 2 times the square root of 36, which is 6, minus 1, so that's 12 minus 1, which is equal to 11. This checks, so my answer is x equals 36. It says, note that radical Rachel isolated the squared term in number 6, step 2. The same way Sam squared isolated the square root term in number 7. Sometimes the squared term is not just an x squared. It may be an x minus 1 squared or a 3x plus 4 squared. Similarly, you need to isolate whatever is under the radical sign. So whether it's a square root of x, or if it's more stuff underneath, we would need to isolate the radical sign. So that's going to be our biggie right here, is to isolate the radical in each equation. All right, so here's one that's more difficult. Let's try to fill in the boxes to solve this one. The first step is to isolate the square root function. So to get this radical thing by itself. How are we going to do that? Well, first I'm going to get rid of this minus 4 by subtracting 4 from both sides. When I subtract 4, my right turns into 2x minus 2. Next, I have to get rid of the 2 that's out in front of the equation. How do I get rid of times 2? I'm going to divide both sides by 2. When I divide this right side by 2, realize I have to distribute it to both things here, so I'll just have x minus 1. Next, I'm trying to get rid of the radical symbol. How do I get rid of squaring? I square both sides, and that's what I did here. I put in a squared. On the left, the squared and the square root are opposites, so all I have left is x plus 1. On the right, I have x minus 1, the quantity squared. When I square in x minus 1, realize I have to FOIL or do boxes when I square this and multiply this together. And what I really have here is x squared minus 2x plus 1. I just rewrote that down here. Now I have to solve this equation. My equation is a quadratic because it has an x squared in it. So when I have a quadratic, I like to set it equal to 0. So I'm going to move my x and my 1 to the other side. So I'll have an x squared. When I subtract x to move it over, I have minus 3x. When I subtract 1 to move it over, I have 0, so I don't need to worry about this part on the end. Next, I factor. I have x squared minus 3x. So all I need to do is take out x as my GCF, which would leave me with x minus 3 on the inside. To solve, I set each factor equal to 0. If I set x equal to 0, I get x equals 0. If I set x minus 3 equal to 0, when I move the 3 over, I'll have x equals positive 3. So I've just gotten two solutions, x equals 0 and x equals 3. I need to check and see if they're going to work. I can do that by plugging into the original problem and checking algebraically. So in this step, I plugged in 0 for x on both the left and the right, so for every x in the problem. If I simplify the left side of this equation, it evaluates to 6. If I simplify the right side of this equation, it evaluates to 2. So since 6 doesn't equal to 2, x equals 0 is not a solution. I need to cross that one off. It's extraneous. I can also plug in 3 to the original equation for each x. If I then evaluate the left side of the equation, following my order of operations, it gives me 8. When I evaluate the right side of my equation, it gives me 8. Since 8 equals 8, x equals 3 is a solution, and it is the only solution to this problem. The other way I could have solved this equation to check to see if it was correct would be to graph the original problem. So on my left side, I have y equals 2 times the square root of x plus 1 plus 4. So this is going to be a square root shape, moved 1 to the left and up 4. And then it's going to have my vertical stretch by 2. So there's that one. And then on the right side of my equation, I had y equals 2x plus 2. That's a line with a y-intercept of 2 and a slope of 2, so I go up 2 over 2 each time. And I can see I definitely have one solution right here. I have one answer. The coordinates at that point, I only care about the x value, which is 3, because x was the only letter in my equation, and that's another easy way to check rather than plug into the original one. So turning to the next page, let's go ahead and try the following. I gave you two equations, number 9 right here, where you're going to have to get that square root function by itself first, and then number 10 right here, which has a fraction, but that's okay, you can do fractions. It gives you the steps, so let's go through and pause the video while you give those a try. It asks you to solve them algebraically on the top half of the page, and then go down and solve them graphically on the bottom half of the page. The answers are there for you to check, so pause the video while you give that a try. Okay, you could pause the video while you take a look at the solutions to both of these. The parts that were the most difficult were the squaring both sides to making sure you either FOIL or did boxes, and at the end, be sure you check your solutions. I'm also going to let you pause the video for a minute while you try the graphing if you haven't done that already. And if you have, just scroll down. So on both of these, I graphed the left and the right side, and I saw where they cross. For me, this method was much faster than doing it algebraically. You also could have graphed the left and the right sides on your calculator and used GSolve or Calc to find the intersection and graph them that way. So let's turn the page and give an example to some times when SAM squared sees two radicals, things work out easier than planned. Remember to continue to check your solutions in the original equation. So you guys see two radicals and think, oh, this one's going to be more difficult. But really in this one, when we square both sides, the squareds and the square roots undo each other. So all you have is that the insides of the square roots must have been equal. So to solve this one, I just would have subtracted 2 from both sides to move, or 2x, sorry, from both sides to move that one over. And also, I'll go ahead and do this all at one time. I would have added 4 to both sides, and then I would have had 4x equals 14. To solve that, I would divide both sides by 4, and that's going to give me x equals 14 fourths. Oops, 14 fourths. I could reduce that if I wanted to, because 2 goes into the top 7 times, and 2 goes into the bottom 2 times. So I get x equals 7 halves. And that's my check down there. I could check by plugging into the original equation, or by graphing both the left and the right sides and making sure that they crossed at x equals 3.5 or 3.5. Those all mean the same thing. And you'll see that those two work out. All right, on number 12, when I square both sides, I have 9u minus 4 equals 7u minus 20. So again, I'm going to subtract 7u to move that over to the left. So then I have 2 u's on my left. And I'm going to add 4 to both sides to move 4 over. So on the right there, I'd have a minus 16. Then to solve that equation, I'm going to divide both sides by 2. And that would give me u is equal to negative 8. So that looks like it's my answer, but in this one, when I go ahead and check, if I do 9 times negative 8 minus 4 all underneath the square root, I wind up with the square root of negative 76. I can't do the square root of a negative number. That would give me an imaginary. So since I'm solving these over the real numbers, I'm not going to worry about my solution of u equal negative 8. So I need to answer no solution. Or I could put the curly brackets with nothing inside of it, or I could do the circle with a line through the middle for no solution. By the way, if I'd plugged the negative in on the right side, I would have had 7 times negative 8 minus 20. So that would have given me the square root of negative 76 again, but even though the left and right sides are the same, we deal with imaginaries. And if you thought about graphing them, they would never cross. Okay, down the bottom of the page it says sometimes the two radicals make the problem more difficult, but luckily we can solve these very easy with a graphing calculator. So in this one, I've got the square root of k plus 9 on the left side, and I've got the square root of k plus the square root of 3 on the right hand side. If I were to square both sides for that thing, it would turn into a big disaster. But I can go to my calculator over here, and I'll just go into the graph menu. I'm going to graph the square root of, and I need to change it to an x. I need to put what's underneath the radical sign in parentheses. Whoops. And then I have the square root of x again, plus the square root of 3. I'm going to go to a nice view window standard and graph that thing, and it looks like they're crossing one time. If I go to gsolve, isect, I can see they cross at x equals 3, and that's my nice solution. I don't care about the y value of the point of intersection because my original equation only had x's in it. So when I answer this technically, I would be saying k equals 3 because I had k's in my first problem. Go ahead and pause the video while you try to do number 14 and 15 on your calculator. You should get these answers right here. All right, when I graph number 14, it's not the prettiest graph ever, but I can still go to gsolve isect, and I can see I get x equals 0.5. I could try to hit the over arrow to see if there's an extra one. There isn't. 0.5 is the only solution. And when I graph number 15 on my calculator, again, it looks like they're crossing once. If I go to gsolve and isect, I get 2.083 repeating. The answer that was on my sheet was 25/12. If you wanted to confirm that, you could either divide 25 divided by 12 in your calculator, or you could also go back into the run menu. Your calculator will remember what x is, and then you could hit the FD button and turn it into a fraction of 25/12. On the back page, we're solving higher degree radicals. In other words, instead of square roots, we might have cubed roots or fourth roots. But really, we know the opposites. We know that to get rid of squareds, Our square roots we square. To get rid of cube roots, we could cube. To get rid of fourth roots, we could fit fourth. In other words, the nth root of x to the n is just x. So if we wanted to solve number 16, I would square both sides, which would give me x equals 9. If I plug back in and check, that's going to work. In number 17, to get rid of the cubed root, I would cube both sides. That's going to give me x equals 27. If I plug back in, the cubed root of 27 equals 3, so that one works. For number 18, to get rid of the fourth root, I'm going to fourth power. So x equals 3 to the fourth, which is 81. And I could plug that back in and double check, and that's going to work also. So in the examples down below, 19 through 22, you're just going to do the same thing. Make sure you have the radical by itself first, and then just raise the power that you need. So in number 19, we're going to cube both sides to get rid of the cube root. So we'd have y minus 7 equals 4 to the third power. 4 to the third power is 64. And then I'd add 7 to both sides to get y by itself, which would give me 71. And if I plug back in and check, that's going to work because the cubed root of 71 minus 7, that's the cubed root of 64, and that's going to be equal to 4, which is the right-hand side, so I know my answer works. In number 20, I would start out by adding 2 to both sides to move the 2 over. Then, to get rid of the fourth root, I'm going to take the fourth power. So on the left side, I'll have a 3x. On the right side, I have 2 to the fourth, which is 16. To get rid of the 3 out in front, I need to divide both sides by 3. So I have x equals 16 thirds. You can leave that as 16 thirds. That's how I would leave it. Or you can go ahead and reduce it. 3 goes into 16 5 times, and there's 1 left over. I'd rather you not call it 5.3 repeating. If you check, you'd plug back into your original equation, and that's the fourth root, of 3 times 16 thirds minus 2 on the outside. So underneath here, these are going to simplify out. The fourth root of 16 is 2, and 2 minus 2 equals 0, like it said in the original equation, so you can tell that one works. Go ahead and pause the video while you try to do 21 and number 22. You can check the solutions on the bottom, or you can wait a minute and then check them on the video. So you noticed on this one, on number 21, I started out, the first thing I did was I moved the 12 over to the right-hand side. And when I did that, I got the fourth root is equal to a negative 5. The fourth root can never be a negative number, so I can stop right there and set no solution. If you were blazing right through this and just kept on going and took both sides to the fourth power, you would have wound up with the solution down here in the bottom of v is 627 sevenths. And then when you go and plug that back into the original equation, you wind up with 17 equals 7, which is an extraneous solution, and you would have crossed it out there. Bottom line, make sure you check your solution. Now in number 22, when you solve that one, and you move the 2 over to the other side, you have the cubed root equals negative 5. That's okay because cubed roots are allowed to equal a negative number, because a negative times a negative times a negative equals a negative. So in this one, when we solve both sides, we wind up with u equals negative 20. And I showed down here that if you plug in negative 20, it does check out, and both sides are equal to negative 3. Come to class next time with any questions if you have them.